Okay, we're going to now continue on with now part 2 on the notes about if-else structures with multiple alternatives. And one thing I forgot to do in the previous video was to demonstrate this program working. And so as we look at this, here it is in JGrasp. And so if we were then to run this, then we enter the magnitude, and so we're going to, let's say, do maybe a 6.2, which is going to make this one true. It should say many buildings considerably damaged. So we'll go 6.2, hit enter, and then as you can see it says many buildings considerably damaged. So it really does work. If we were to pick something, let's say that's as low as we could be, below the 4.5 threshold, so like something like a 3, it should say that there's no damage, so no destruction of buildings. So you can see how that it does actually work. Now we're going to deal with another situation here. As we saw in our previous program when we dealt with the college tuition, we used a series of if statements. Okay, so a series of if statements can be appropriate, but the question is a series of if statements appropriate for the Richter scale program? And so once again, let's just take a look at the college tuition. You'll notice that after we got the information from the user, then we could go in there and say, well, if the age is greater than or equal to 50, well, we'll give this discount. If they're part of Arizona, then we'll give this discount. So what happens with the if everything is an if, that means that the compiler is going to engage every single if statement. Every single one of these will be engaged. Alright, so it's possible that every single one of these clauses would be executed. But remember, the difference here is that in the if-else structure, remember how we talked about that only one of these alternatives is going to be executed. So there's a major difference here. So if you look at this, and the way that you would test this out, and it would be really cool if you could test this out yourself and see what you think. Is it appropriate? Is this program appropriate for using just if structures? And the way you would test that out is you would take a value, and let's take something like 6.2. Is 6.2 going to produce the same result as it did before? Well, so let's go up here. You go 6.2 is it greater than or equal to 8? Well, no, so this is ignored. We're looking good so far. It goes now, because notice this does not depend on this. This is going to be run, this is going to be evaluated no matter what, because it's an if. A compiler has to execute or to evaluate every if condition. And so is 6.2 greater than or equal to 7.0? Well, no, it's not. So this is going to be ignored. Okay, so now we go see, is 6.2 greater than or equal to 6.2? Yes. So this gets executed right here. Okay, now the program keeps going, and because it doesn't say else if here, it says if. That means that the compiler has to engage in this if statement and evaluate the Boolean expression or the condition. Is 6.2 greater than 4.5? Well, yes, it is. Therefore, the compiler is going to also display that damage to poorly constructed buildings. Alright, that's a problem right there. And then here we go. Is it greater than 0? Yeah. Well, it says no destruction. So does that really make sense? That all three would be true with one Richter scale reading? No, that's not going to make sense. And so you can see here that in this case, if does not work. To have all if structures work, all right, what I'm trying to say is to have each alternative have an if statement, that's just not going to work. And so if we were to look at an example here and run that, and let's just see. So here it is with all ifs. Alright, so it's got all ifs. Now let's run it with the 6.2. See if it came out like what we thought. And so if you look at it here, after the 6.2, we see that it did this and it did this. I think I wrote this differently. I didn't do the else is greater than 0 or something. So anyways, so it printed multiple effects, which doesn't make sense. And so as we go back to our notes then we can go, well, when is a series of if statements appropriate? All right. Well, it's when the alternatives are not related or dependent on each other. So when is a series of if statements appropriate? It's when the alternatives are not related or dependent on each other. And this is probably a better one. When each condition must be evaluated. When is all if statements appropriate? When each condition must be evaluated. And so if we look again at the college tuition situation, after the student enters his data, then the age of the student has to be evaluated to see if they get the discount for the age. Then the residence, their place of residence, well, that has to be evaluated. Is it Arizona or not? It doesn't depend on their age. It has to be evaluated to see if they get that discount, because it makes sense for them to get more than one discount. And here the name, this has to do with the first name. These two things, these two alternatives, they have to do with the name. And so now each one of those is a possible thing. So each one of these should be checked to see if the student even gets those discounts. So it makes sense that everything, each one of these needs to be evaluated, and it's possible to get more than one discount. And so now we look back at our notes and we say, when is an if statements, a series of if statements appropriate? When each condition must be evaluated, and if else is necessary in a set of alternatives only when it makes sense that only one alternative be executed. So if else is necessary when it makes sense that only one alternative be executed. So in the Richter scale program, it makes sense that only one be executed. You can't have most structures will fall and then no destruction at the same time. That doesn't make sense. But with the college tuition thing, it didn't make sense that only one discount be applied, because it's possible that more than one discount could be applied. Alright, let's move on. In the Richter scale program, a magnitude of 7.3 produces multiple true conditions. And so if we look at this, we can see how 7.3, let's say that, I think that's what it said, if it's a 7.3, well, 7.3 is greater than or equal to 7.0. It's also greater than or equal to 6.0, and it's also greater than or equal to 4.5. So each one of these would be true by a 7.3 reading. Okay, so that could be cause of concern. So, well, what happens then is, why doesn't it execute all three branches? And how does the compiler know which clause to execute? And so the reason is because of what we just talked about up here. The compiler evaluates each condition until it in order. So it's going in order from top to bottom until it finds the one condition that is true. Alright, and then it executes that clause. Alright, the other way we could say it is that the clause associated with the first condition that's true will be executed. So that's why it's always going to get the right one, because it's going to go in, if you write the program correctly, it's going to it's going to take the first one that's true and then ignore everything else. Takes the first one that's true, ignores everything else. Alright, so let's go down to 24. This is the last thing we'll deal with. And does the order in which the conditions appear matter? So let's say that we were to we use our if and else if statements here, but what if we reverse the order? Instead of starting with the top number, the largest, let's go start with the smaller number, or the smallest number, and work our way up. Well, if we do that, we would find that we have to be really careful. And so what I would ask you to do is actually to pause the video and test something, a value, see if it makes sense. So for instance, let's take 7.3. So so let's take 7.3. Well, is 7.3 greater than or equal to 4.5? Well, yes it is. And so it would say damage to poorly constructed buildings. The problem is, it says damage to poorly constructed buildings. The problem is 7.3 in this chart says many buildings will be destroyed. Okay, so that's a problem. It's not going to work. And you would find that if you would do other ones, it's going to do the same thing. So 7.3 would get to here, and then it would stop. Because it would ignore the rest. So that's going to cause issues. So the thing that I had students do in class is to, well, let's keep this order, but make changes to make it work. And so if you're feeling courageous here, then this is something you should try. In fact, there's in today's module there's a program called Does Order Matter, and you could download that and you could try this in JGraphs and try to make it work. And so we have an example here of Does Order Matter. So here it is originally, and of course this is where we demonstrated that if we were to enter a number like 7.3, it doesn't give the right thing. Alright, so it says damage to poorly constructed buildings. It should be something else. Well, here is, that doesn't mean you can't do that. You can do it, but you have to make some changes here. So you can start with the lower number, but you have to be careful. You have to adjust your Boolean expressions. So here you notice we're going from 4.5 to 6.0 to 7.0 to 8.0. So we're going in the opposite order of our original solution. But notice here that we changed that Boolean expression, the relational operator, from greater than to less than. So now this accommodates everything from 4.5 and or everything less than 4.5. And then the next one accommodates 6.0. It says less than 6.0. So it accommodates everything from 6.0 down to 4.5. And then the next one accommodates 7.0 to 6.5 because it says less than 7.0. And then the 8.0, it says is less than, so it accommodates everything from 8.0 down to 7.0. Notice we don't use the equal sign because it at 7.0 is supposed to be the other one. Okay, so you got to make sure that you decide whether you need the equal sign or not. And so now notice that we've covered everything from 8.0 on down. Well, what about greater than 8? Where's that at? Well, that's here. Whoops, that's else. Else covers everything else. Well, what's left? The only thing that's left here is above 8.0. So now you've got everything accommodated for, no matter what, by going the opposite direction. All right, so it can work. You just have to make sure that your Boolean expressions are correct. So let's go back to our notes and see what we have going here. Okay, so that's what we did here. So the last thing we want to mention is that an else-if branch, can be used as the last alternative. Okay, the else-if branch can be used as the last alternative. If you'll remember up here, all of our examples, we showed else being the last one. And as a general rule, that's typically what's going to work the best. However, you can finish with an else-if branch. And so in this case, if you try to use an else-if, the important thing to understand here is that tracing and testing the code, will help you assess whether else or else-if is the most appropriate as the last alternative. So that would be important to check that out. Alright, so that's it for the multiple alternatives with an else-if or an if-else structure.